Use a compound angle formula to show that cos of 90 degrees minus A is equal to sine of A. So we're going to go with the compound angle formula. Cos of A minus B is equal to cos of A cos of B plus sine of A sine of B. So the reason that I've chosen this formula of the 6 that we are given in our formula book on page 14 is because in our question we were given cos of something minus something. And in your formula book, the only formula that is cos of something minus something is cos of A minus B. And that is equal to cos of A cos of B plus sine of A sine of B. So the 90 degrees represents the A and the A represents the B. So everywhere on the right hand side of our equal sign in our formula that we see an A, we're going to swap it with 90 degrees. And everywhere that we see a B, we're going to swap it with A. So cos of 90 degrees minus A becomes cos of 90 degrees, because we swap the A for 90 degrees, cos of A, because we swap the B for A, plus sine of 90 degrees, because we swap the A for 90 degrees, sine of A, because we swap the B for A. We make sure that our calculator is in degree mode if we're using our calculator. And cos of 90 degrees gives us 0. So we swap cos of 90 degrees for 0. And that's still stuck on to cos of A. And sine of 90 degrees gives us 1. So we swap sine of 90 degrees for 1. And that's still stuck on to sine of A. So we end up with 0 cos of A plus 1 sine of A. And 0 multiplied by anything just cancels out. And 1 multiplied by sine of A just leaves us with sine of A. And that's what we were asked to prove. These results are sometimes called the complementary angle results and are true for all angles A. They are needed for the proof of Formula 7. Part 2. Use a compound angle formula to show that sine of 90 degrees minus A is equal to cos of A. So we're going to use what we worked out in part 1. So in part 1, it was stated that cos of 90 degrees minus A is equal to sine of A, which we can swap around to say sine of A is equal to cos of 90 degrees minus A. So we now have sine of 90 degrees minus A. So using our formula from part 1, we're going to swap that A for 90 degrees minus A over here. So we're going to have cos, bring down the cos, of 90 degrees, bring down the 90 degrees, and the minus, and we're swapping that A for 90 degrees minus A. So we have cos of 90 degrees minus 90 degrees minus A. The minus is in front of the brackets, so it's going to be minus multiplied by 90, which is just minus 90. And that will cancel out with a positive 90. And then minus A gives us positive A. So we end up with cos of A. And cos of A is what we were asked to show. So another formula that we have of our compound angle formulae is cos of A plus B, which is equal to cos of A cos of B minus sine of A sine of B. Very, very similar to the last formula we looked at, except we have a plus here instead of a minus, and a minus here instead of a plus. This is on page 14, along with the other compound angle formula. Important to note that these two formulae that we were working with in the last slide are not in the formula book.